Alright guys, so today we'll be going over what we learned in class, which was first order linear or linear first order differential equations, and they look like this. D of y over d of x plus p of x y equals q of x. This is your standard form for a linear first order differential equation, and the way you solve these is first identifying your p of x, then identifying your q of x, and then using your p of x right here to find the integration factor, which is always this. It's always exponent, integral, your p of x, and yeah, this will result in your integration factor, which you will then multiply with all of these. So if multiplied by f multiplied by f integration factor, and once you do that, you integrate this side of the equation. Well, first you have to find a equivalent to this side, which I'll explain to you more in detail once we go through like the first problem. But yeah, let me actually just do that right now. Okay, so we'll do a quick problem just so you can understand how this works. We'll start with 1.3.7 in the book because it's pretty simple. It'll get you to understand how this works better, and yeah, you'll just get more comfortable. Y prime plus 3 over 5. Wait, what? Y prime plus 3 over x, y equals x. All right. So first, identify your p of x and your q of x. Here we have our p of x, and here we have our q of x. And we want to find the integration factor. So if is equal to, remember, exponent integral of your p of x, 3 over x dx. And this is going to be e, take that out, so you get 3 natural log of x, because if we remember, the inverse of any function, like x squared, is always, or let me get that right actually. Inverse of any function is always going to be the natural log of that. So just a quick recap of your previous calculus classes. I'm sure you remember. But, oh yeah, and we will get a plus e, but you can just ignore that because it's arbitrary and you don't need it for your integration function. So just ignore that. And then we'll finish this real quick. Just do some, remember these bases, or this is the base of that, or whatever. You already know. You can cancel these out. So this is still an exponent, so you'll end up with x cubed. That ends up with x cubed, and this is your if. Once again, x cubed equals if. Okay, and remember, we're going to multiply these out. So x cubed, just for the sake of standard form, dy over dx, plus x cubed, 3 over x, which we know cancel these out. We get x squared, 3x squared. Oh, there's a y. Yeah, let me just cube dy x plus. And then we have your qx here. Multiply them equals to x4. And so now what we want to do is we want to find like an equivalent to the left side of the equation, just to kind of be able to integrate the right without having all these complex numbers. So we do this by, okay, so we have these numbers, and what we want to do is we have x cubed y prime, right? Dy over dx, derivative of y with respect to x, right? And we solve this real quick. We end up with, 3x squared y plus, because we have to use product. We have to use product rule. So remember, when you're using product rule, you take derivative of this and then you take derivative of that. You have to add them. So we end up with x cubed y prime, which if we look, this is equal to this right here, and that is equal to this. So essentially we can just use x cubed times y. So just label these. Step 1, identify. Step 2, which is all of this right here. Step 2. Step 3, find an equivalent. Usually you just have your identification or integration function. Sorry, I keep saying identification. Usually you have your integration function multiplied by y, and then you take the derivative. And that's usually what ends up being the left side. So that's step 3. And then step 4 is you integrate the qx. Yeah, so remember we got x cubed y prime equals, we ended up with x to the power of 4. So now we just want to get rid of this prime. So we integrate, get rid of that, just get rid of it. Integrate x to the 4, which is equal to x to the 5th divided by 5 plus c. So now we have x cubed y equals, x to the 5th over 5 plus c. And now we want to isolate the y, so we divide this by x cubed, divide all that by x cubed. And you know what happens when you divide exponents? They cancel out. Well, they don't cancel out, you subtract them. So you end up with y is equal to x squared over 5 plus c over 3x. C over x cubed, sorry. Just make sure that's clear. So that's your solution for 1.3.7. Yeah. So remember, find p of x, q of x, find your integration factor, and then from your integration factor, you do some arithmetic to find the left side, or I guess it's more calculus actually. Do some calculus to find the left side, an equivalent to the left side, and then you integrate the right side, so you can get rid of that derivative. And there you go. So now we'll just do some of the problems we did in class. Come on. The most flimsy whiteboard in the entire world. But I like it. Really nice. All right. So we'll do 1.3.11. Yeah. Okay, so this one's a little tricky. 1 minus x squared times dy over dx minus xy equals 1. So remember, find your p of x, q of x. But there's an issue here. This isn't standard form because we have this guy multiplying with the differential, or just the derivative over here. So we have to divide. Divide. We end up with dy x minus x over 1 minus x squared times y. Yeah. Is equal to 1 over 1 minus x squared. Yeah. So now here's your p of x and your q of x. And then we find our integration function, which is this right here. This one's a little tricky, but we got it. Remember, exponent, x over 1 minus x squared dx. Okay. So we're going to use some u substitution. Yeah. So u equals 1 minus x squared du, right? Yeah. Du equals negative 2x dx. So we'll just focus on this one real quick, this side. So we have, that's way too big. We have, let's see, 1 over, I like separating these. 1 over 1 minus x squared, which is u now, right? And then our du, we can just divide negative 2 times, and then you end up with x dx, which is this function. So times du over 2. And this is, yeah, negative 1/2 integral d over u, which is equal to negative 1/2 times natural log of u. Let me make sure that's good. Yeah, has to be good. So remember, our u was 1 minus x squared. So ln 1 minus x squared plus c, but we don't need the plus c. So yeah. So here is your integration function, e negative 1/2 ln 1 minus x squared. And we always cancel these out. And this is an exponent. So we end up with 1 minus x squared. We already know what that is. Boom. Let me write that here, actually. That's your integration function. Wait, no. What? Something's wrong. Oh, wait. So stupid. Yeah. All right. I see the issue here. Big problem. There's a negative, and yeah, because there's negative here, that's part of the P of X. Just a mistake I made. We all make them. So that kind of messes everything up. So where is this? Okay. So we would end up here. And since this is negative, these kind of cancel out. So you actually end up with the positive. And you don't end up with that. You end up with something else because this is positive. So we almost had it. You would just end up with that. That's your integration function. Okay. So just remember that. I'll write it down again here. Okay. We were at minus, what was it? Equals, okay, did that. Our integration function was 1 minus x squared. All right. So now we multiply this. 1 minus x squared dy dx minus, yeah, x squared. Okay. This is pretty fancy here. Do some fancy math. So, as John Dye would say, the devil's in the details. So we basically have this. Pretty basic shit. Oh, can't curse. Yeah. You know what? You have that. So let's just rewrite this. There's still an x here. That would just be 1. Oh no. It'd be the same thing actually. Let me check. Let me check. Make sure I'm not doing anything wrong. Yeah, should be. All right. Okay, so once again, we get our integration function. Multiply by y. Take the derivative. And what do we get? We get, let's see, first we do this one. That's 1/2 times 2x. All right. Yeah. Negative 2x All right. Oh, there's an x. Future x. Okay. So this, boom. That's one part. Then we have product rule, so we have to derive the y. Pretty easy. 1 minus x squared times y prime, which is what we have right here. So yeah, here is your equivalent. So I'll keep that. Yeah. 1 minus x squared y. So we have 1 minus x squared times y prime equal to 1 over, oh, it was in the other one. 1 over 1 minus x squared. Yeah. So then we just integrate. This is your q of x now. Integrate q of x. So squared y equals integral. Well, integral of 1 over root 1 minus x squared dx. And if we remember from Calc 2, Calc 2, this is arctan. Let's see. So our final solution, arctan over 1 minus x squared plus c over 1 minus x squared. Boom. There you go. Yeah. So I'll just have one more because I'm kind of running out of time. This one's kind of funky, sort of, just because it has decimals. Wouldn't really work with them that much, but you have to get used to that. So we'll just go over that real quick. Really, really quick. Shouldn't be too bad. Ooh, okay, this one's nice. Yeah, dy. Oh, this is 1.3. 1, 2. dy over dx. 0.02 y equals sine of x. Yeah, so this one also has some fancy smanchy arithmetic in the calculus part of it. Oh yeah, here's just a what y at 0 is. Yeah. Okay. Identify your p of x. Identify your q of x. And we do what we've been doing for the other problems. So, as you might have assumed, find your integration function equal to, 0.02 x dx. Remember this, sorry, I should probably do it. This whole thing that's not the y is your p of x. So the x is included, this one. So this is equal to e, e 0.01 squared, or it could be 0.02, right, over 2. But divide that, you get 0.01. So just so you know what's going on. x squared. Yeah, this is your integration function. Okay, so now we got that. Just erase this because I always run out of space. I have it here. IF equals E squared. Okay. So we do what we've been doing for all the other ones. E 0.01 x squared dy dx plus E 0.01 x squared 0.02 xy 0.01 x squared times sine x. Yeah. Okay. Just make sure. Just double check. It's always good to double check your work. Looks pretty good. Looking pretty good. So remember, you get that. You get your integration function, and you multiply by y. Oh wait, not literally spell IF, but you get your integration function. Multiply by y prime. So you get your. So you can confirm that this will replace the left side of the equation. So first you do this. 2x times E 0.01 x squared y, because remember, yeah. And then we have to, do the y side of things. So y prime equals to this. Okay, so this will replace the left side of the equation. That whole thing. So now we have E 0.01 x squared y prime equals 0.01 root sine x. So here's where we use some fancy schmancy integration. So we'll integrate this right here. And then what he does, he does this, some fancy stuff. So you can divide that right now. Yeah, you'll get 1 over 1 x squared y, which is actually E negative 0.01 x squared y times the integral, but he does this. He replaces x with s. So x, it's like limit x to s or something, but yeah. So 0.01 s squared sine s. Oh, and the reason he does that, I think it's a limit. Could be wrong. This is what I'm thinking. Yeah. Limit. Wait. Limit something. I don't know. I'm getting off track. Limit x to 0 or something is equal to s. Something like that. Could be wrong. Could be very wrong. But this is what he does. And the reason he does this is because if we remember, when y is equal to 2, or when y at 0 is equal to 2. So we can replace that x with the 0. So we get e negative 0.01x, or I guess 0 actually, 0 squared. And then that is 0 to 0, because instead of 0 to x, we replace x with 0. 0 to 0, we still get e so y is actually equal to, and I mean, when you take an integral from 0 to 0, we already know, starting at 0, you're not going anywhere, you're just staying at 0. So you're not doing any of this. You're just staying here at 0. So yeah, and then e to the 0 is 1. But, right? Yeah. Is that correct? Oh wait, no, it's 0. It has to be 0. Yeah. What am I tripping? So tripping. Wait. Yeah. Okay. So since we replaced x with 0, y must equal to 2. So instead of this y, we have a 2. So 2 is equal to, all of this is going to be 0 actually. Because this is automatically 0, so even if you get a 1 here, get a 0. 0 plus c. So c is just equal to 2, or negative 2. Right? Oh wait, no, what? Tripping. Yeah. So c is equal to 2. And then just for the general solution, of our differential equation, y of x is equal to e to the negative 0.01 x squared, 0 to x. Yeah. Okay, we're good. Yeah. Oh, plus 2. You know why? You know why it's plus 2? Because c was equal to 2, remember? Plus 2. Because c was equal to 2. So here's your general solution. Yeah. So that was pretty much what we learned. Linear first order differential equations. And I hope these practice problems helped you out. If they didn't, send me a message and I will help you. But yeah.